Hi, this is Peter Smallage. I'm the director of the Cornell University Arnot Teaching and Research Force, and I'm hosting the 2012 Undergraduate Intern Webinar presentations. It's my pleasure today to introduce Cassie Garcia. Cassie will be talking about her evaluation of the effects of natural gas pipeline development on amphibians and reptiles. Cassie, welcome, and the floor is yours.
Hi Pete, thank you once again. My name is Cassie Garcia, and today I'm going to be talking to you about evaluating the effects of natural gas pipeline development on amphibians and reptiles. My advisors for this project were Christy Sullivan and Steve Morreale. Before I begin, I wanted to say a special thanks to the Arnot crew that helped with this to make this project possible this summer, and that included Peter Smallage and Kathy Coates, along with Gary Goff. And I also wanted to extend a special thank you to the other interns that helped me, who were Seth, Devin, and Drew. The reason for this project stems from the infrastructure for this shale gas extraction. When most people think of natural gas extraction, they think of well pads. And these are important to the gas extraction process. They vary in size between 3 to 5 acres, and they are where the natural gas is stored after it's been extracted, and do play an important part in the process. Along with shale gas extraction, though, there are pipelines, and these also play a very important role in the extraction process because they connect the gas from the well pads to areas where they can start to be used, and they can extend for miles. They vary in size as well, between 10 to 20 meters in width, and so they are more narrow than well pads, but as we will see, they do have quite an impact. So in 2002, the Nature Conservancy conducted a study and found that 60,000 new wells are projected to be in Pennsylvania by 2030. And this means that between 6,000 to 15,000 of well pads will be added. The land that these well pads will be on is projected to be 2/3 of forested area, and this leads to between 34,000 and 83,000 acres of permanent forest removed. This is a large quantity of forest that will be permanently removed. And before I begin, I just want to point out that this is in Pennsylvania alone that these statistics come from, and New York could possibly. New York is on this path to also have shale gas extraction, so this is an important topic and relevant to today. So this is, like I said, a large man that will be removed, and it will not be removed as a chunk. It will be removed as slivers, and this leads to fragmentation, as can be seen in this image from Bradford County in 2008, and then also when they added the pipeline and well pad in 2010. So it splits this continuous forest into 2 pieces. This not only changes the quantity of a forest, but it also affects the quality of forest. So fragmentation from pipeline openings on adjacent forests has great effects. These effects include an increase in temperature, light, and wind, along with a decrease in soil moisture and habitat quality. And these culminate to have an overall impact on ecosystem health. For this project, we chose to focus mainly on amphibians or reptiles, as can be seen by this redback salamander, since they are indicators of these impacts. For our study, we were interested in 2 main objectives, and the first was to determine the effects of gas pipelines on forest amphibians, mainly salamanders, reptiles, mainly snakes, and other invertebrates. And we are also, along with this objective, we are also interested in seeing how far do these effects go into the forest. Do they stop after 10 meters, or do they extend past 100 meters? Our second objective was to look to see if there are any techniques that we could develop that might mitigate these pipeline impacts. Our study area was in northern Pennsylvania, and we worked at 3 different sites, as can be seen by these stars. And these sites are in predominantly rural and forested landscapes. This is a picture of this is a satellite image of one of our sites, and you can see the pipeline along with the well pad. And as I said before, the first part of our study looked at the effects of the pipeline from the forest edge into the forest interior. And we are also interested in knowing what distance or how far these effects reached into the forest interior. So to establish this, to look at this objective, we established two types of transects from the forest edge into the forest interior. The first transect that we established, it can be seen by the yellow line, which is a 100-meter natural cover transect. And the second type of transect that we established was a 50-meter coverboard transect. And the coverboard transects also had temperature and light loggers that were along the transect, so we could measure the temperature and light as you go from the forest edge into the forest interior. So natural cover transects include flipping over, turning over everything that is above a certain size. So turning over rocks and sticks that are bigger or above a certain size. And the area that we would walk along the transect and turn over, flip over objects was 2 meters in width. The natural coverboard transects, as can be seen in the right photo, include flipping over a board that we place down that is about 2 feet by 1 foot, and they were every 10 meters along the transect. And as stated before, we also had light and temperature loggers along these transects as well. So the results that we got from the temperature and light loggers, we found that from the pipeline edge into the forest interior, there's a significant decrease in both temperature and in light. And this is due in part to a substantial difference from the pipeline edge into the forest by initial 10 meters. And this decrease in both temperature and in light could have a possible effect on salamanders and affect their habitat. So when we looked at the coverboards, we analyzed that data that we had gathered from the coverboard transects, and we found that from the forest edge, pipeline edge into the forest interior, the amount of salamanders increased. And we found that although there are many site differences, there's a strong effect for the first 15 meters, and this could possibly extend further into the forest. When we analyzed our natural cover transects, we did a regression analysis, and we found that from the pipeline edge into the forest interior, similar to the coverboard transects, that the number of redback salamanders increased significantly. The natural cover transects have a more complex mixture of components, and we explored this further by conducting a multiple regression analysis and found that sticks and rocks significantly affect the number of redback salamanders. As mentioned before, one of our objectives to this project was trying to develop techniques to mitigate the pipeline impacts of which I just spoke. So we did this by having areas that had piles, as can be seen in the photo on the right, that were made out of large logs in the pipeline opening, and we compared this to areas where there are no piles. We compared this to open areas. We also placed temperature loggers at the center of the piles and at the center of the open areas to compare the temperature between the two. We had an array of cover sheets and cover boards. The cover sheets are made out of tar paper, and the cover boards were the same cover boards that I had spoke on before. And we placed these around the piled areas and no piled areas. And this diagram on the left shows an open area compared to a piled area with the cover boards designated by the little brown rectangles, and the cover sheets designated by the black rectangles that were in the pipeline opening. And we would check the cover boards periodically throughout the summer. So the results that we gathered from the cover boards, the first thing we looked at was the mean number of salamanders per board. The redback salamanders, as can be seen on the left side in the red bar graph, red bars, they preferred the piles to no piles, where the other two types of salamanders preferred the piled areas compared to the piles. That was when we looked at all the seasons. But then we decided we wanted to possibly break down, was there any difference between season? And we found that there was. During the summer months, there were hardly any salamanders that could be found on the pipeline, and the few that were preferred the piles versus the no piled or opened areas. When looking at the cover sheets, this brought on a different set of animals, namely snakes and surprisingly mice. The snakes typically preferred the piled areas compared to the mice, which typically preferred the opened areas. However, once again, when we broke down into seasons, we found that the summer months there were hardly any animals, and that the snakes once again preferred to be in the piled areas. What we found when we went out into the field and were looking under the cover sheets was that it wasn't, found that there was actual interest to the position of the cover sheets, more than just piled areas versus no piled areas. And so we saw that snakes and mice seem to have a preference of being closer to the edge. And you can see that they indeed did like to be closer to the edge by looking at this graph and the diagram, and that the one position, which is closest to the forest edge, did have the most animals when in the pipeline. We analyzed the temperature data that we collected, and we found that the piles are typically cooler than areas without piles, and that there was greater temperature fluctuation in the areas without piles. The red piles, the piled areas, which are designated by the red dots, you can see do have a lower fluctuation and just generally lower in temperature. And so it is no wonder that the snakes and redback salamanders preferred the piled areas in the heat of the summer. In conclusion, from the pipeline edge into the forest interior, there is a decrease in both temperature and light, along with an increase in salamanders. The impacts of the pipeline is more severe in the summer than compared to the fall months, and placing piles in the pipeline as a mitigation technique may be beneficial for salamanders, but furthermore, placing cover objects along the forest edge may be better for other types of animals such as snakes. Thank you so much for your time, and I hope this was an informative webinar.
Thank you very much, Cassie. That was a great presentation. Thank you all for participating.